Spirit Algebra students, Mr. Lawrence here with your flipped lesson, and I know we're in the home stretch, but we got a lot of work to do before we're ready for the final. I first off have to say how proud I was of you guys Friday. Your mastery, your understanding of adding and subtracting fractions was way beyond where I expected to be, and I'm very encouraged by that. You weren't bad with multiplying fractions, and I think as you see more and more how to do it, it'll get a little bit easier. So that being said, I'm not going to spend any more time on it since you already have the skills you need. We're going to get right into adding rational expressions and determining restrictions. And I'll explain restrictions first. All right, restrictions are numbers that x cannot be. Restrictions are numbers at x or a variable x cannot equal. For example, if you look at this first fraction here, 1 over x, some of you know right off the bat x can't be 0. So one of the restrictions for this problem is x cannot equal 0. That's one of the restrictions because it makes that 0. Another one would be whatever makes this 0. Well, I could go x plus 1 equal to 0 and solve for x, and I'll get x equals -1. So the restriction is x cannot equal -1, because if x is -1, I get 0 for the denominator, and you can never have 0 for a denominator. All right, well, now that I know my restrictions, I'm going to go ahead and find my LCD so I can add these two fractions. So let me see here. Let me get a nice poiple going. All right, I'm going to do my LCD. Now, what is one number that has to be a part of my LCD? Well, x has to be. This x can represent that x. Can't represent this one because that's not an x. That's one more than x, or an x plus 1. So I need an x for my LCD. I'm also going to need an x plus 1, and that will represent this guy. Now, I'm going to change my fractions so that they have the LCD. I'm going to end up, hold on one second, I'm going to end up multiplying each fraction by a certain number. What number, you ask? The number that will give me the LCD, just like you would have in class on Friday. So I'm going to look at this first fraction here, and I'm going to see that it has an x in the denominator, but it doesn't have an x plus 1. So I'm going to multiply by x plus 1. But if I do it in the denominator, I have to do it in the numerator. So I'm multiplying the numerator by x plus 1 and the denominator by x plus 1. So my new fraction becomes x times x plus 1 as a quantity times 1, which is just x plus 1, over x times x plus 1. And you might be saying, should I distribute that? I'm going to tell you not to. All right, now I have to change the second fraction so that it has the LCD. And it has one of the factors of the LCD, namely the x plus 1, but it doesn't have the x. So I'm going to multiply by x in both the numerator and denominator. And so this fraction will turn into x over x plus 1 times x. Well, now that I have my LCD, x times quantity of x plus 1, both fractions match, have the same LCD. I can just combine my like terms in the numerator. So it looks like I'm going to have 2 x's plus 1. There we go. And of course I want to say when, oops, I switched on that, sorry. When x doesn't equal 0 or -1. So there is my answer right there. Just like that. All right, let's look at the next problem. Okay, I'm going to go find my restrictions first, and it looks like x isn't going to be 0. Right there. What will turn that to 0? Well, I can go 2x plus 1, set it equal to 0. Solve for x. Divide by 2. X will equal -1/2. That would be -1/2. So there's my two restrictions. X cannot be 0, x cannot be -1/2. Now I go looking for my LCD. So to find my LCD, I'm going to consider all the numbers that are going to have to be a part of my common denominator. I'm going to need an x, and then I'm going to need this 2x plus 1 guy. My LCD is going to be that. Remember, that's one number. That's one more than double what x is. If x is 5, then this is 11. One more than twice x. All right, so here's where I multiply. On this first problem, I'm going to need to multiply. Ooh, that didn't change color. Going to multiply by 2x plus 1 in the denominator and in the numerator. Here, I'm going to have to just multiply by x in the denominator and the numerator. I'm going to distribute here and get a 10x plus a 5 over the LCD. And I have a 3x over the LCD. And so that's going to equal, combining like terms, 10x, oops, not 10x, 13x plus 5 over the LCD of x times quantity of 2x plus 1, where x does not equal 0 or negative 1/2. Those are the restrictions. And so there's your answer right there. All right, another example. Now, this one's going to fool you. Hopefully, you're recognizing that x squared minus 1 is factorable. And so I'm going to factor that into x plus 1, x minus 1. Okay, always look to factor. So I'm going to go find the restrictions. I know that x cannot equal plus or minus 1. Go looking for my LCD next. So my LCD, I'm going to need an x minus 1. That'll cover this guy. And the cool thing is, it can cover him too. They're the same number showing up twice. Okay? It's very, very important. I want to go off on a tangent here. If I want to know the LCD of 1/2 and 1/4, the LCD is not 8. That's a common denominator, but it's not the LCD. Can't I think of 4 as 2 times 2? So, if I do that, when I go looking for my LCD, I know a 2 has to be in my denominator. But that 2 is represented here as well. I don't want to over-represent them. And then I'm going to need a second 2, which will take care of that guy. So my LCD is actually 4, not 8. I don't just multiply the denominators together. I factor the denominators if possible and see which factors need to be represented. Okay, so I've got this x minus 1. I'm also going to need an x plus 1. Now this first fraction here, I'm going to rewrite it. It's 2 over x plus 1, x minus 1, and then plus 5 times x minus 1. The first fraction isn't missing anything from the LCD. It has an x minus 1 and an x plus 1. So I'm not going to do anything to that fraction. The second fraction's denominator only has x minus 1, so I'm going to multiply it by an x plus 1, and I'll do the same in the numerator. Of course, I'll distribute here. I'll end up with this, 2 over my LCD plus 5x plus 5 over my LCD. And I'll combine them like terms of my numerators over my LCD. And this is true when x does not equal plus or minus 1. And there is your solution. It's actually not a solution. There's your simplification. Your sum, I should say. Okay, example number 4. Again, we're going to factor. It looks like a GCF problem, so I'm going to pull an x out and be left with an x plus 1. Now when I go looking for my LCD, I know I'm going to need an x, and I know I'm going to need an x plus 1. When I write the number over here, it can represent itself one time in every denominator. By the way, I don't want to forget to do my restrictions. It looks like x is not going to be allowed to be 0 or -1. Okay, this first fraction, the 6x over x times quantity of x plus 1, already has the LCD. I won't do anything to it. The second fraction is missing an x in the denominator, so I'll multiply. So I'm going to end up with 6x over x times quantity of x plus 1 plus 3x over x times quantity of x plus 1, and that's going to equal 9x over x times quantity of x plus 1, and that'll be true when x does not equal 0 or -1. And there you go. Pretty easy stuff. Pretty easy stuff, especially as well as you guys understand fractions. All right, couple more quick examples. This one going to factor. Looks like a trinomial, and it's going to factor x plus 2, x plus 3. Go looking for the LCD. Know I'm going to need an x plus 3. That number can represent itself one time in every denominator. Is everything represented? No. I need an x plus 2. I'll represent him. Now everything's represented. I think I'll find my restrictions before I go and do my multiplication. Now, I see that the first fraction has the LCD. The second fraction needs to be multiplied by an x plus 2. Right? And so I'll have 7 over the LCD. And then I'm going to distribute here and get 2x plus 4 over x plus 2, x plus 3. And now I'll combine my like terms. 2x plus 11 over x plus 2, x plus 3. That, of course, is true when x does not equal -3 or -2. Okay. Were those numbers, we wouldn't be able to do this problem. All right, one more example. Hopefully you're writing all these down, paying attention, thinking about it. Okay, going to look to factor first. Have I mentioned that enough times? Looks like that's going to factor twice. Pull an x out, x squared minus 1. And then this is going to factor as x plus 1, x minus 1. Now I notice something else. Before I find my LCD, I'm going to do this. 4x over x times x plus 1, x minus 1. Notice how that denominator is all multiplication. 5 over an x plus 1. Before I go find my LCD, I'm going to notice that there's a 4 and an x attached by multiplication right here. And this x is attached to multiplication right there, to the quantity of x plus 1 and quantity of x minus 1. And there's a division bar, the fraction bar. These x's can cancel out, leaving me 4 over x plus 1, x minus 1. Now I'm ready to go find the LCD. What did I just do there? I simplified my fraction. All right, I'm going to need an x plus 1 in my denominator. Shoot, shoot. Going to need a quantity of x minus 1 in my denominator. Shoot. Go find my restrictions. Now, my restriction, a lot of you are going to say, well, it can't be plus or minus 1, and you're right. But also, you see this one here? Before I cancel them out, x couldn't be 0 either. There's actually a third restriction. Okay. So now, the first fraction has the LCD. I won't do anything to it. Second fraction is missing a quantity of x minus 1. And now I'm going to go ahead and you have 4 over x plus 1, x minus 1, plus, got to distribute here, 5x minus 5 over the LCD, x plus 1, x minus 1. That's going to equal 5x minus 1 over the LCD. That'll be true when x does not equal plus or minus 1 or 0. And there is your sum. Pretty crazy. Don't worry, we're going to get some practice with this in class today. Mr. Lawrence signing off. Good night, everybody.